Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed about the pressure exerted by a fluid. We have seen what is the numerical formula which can give us the value of the pressure exerted by the fluid. We have also discussed to some extent about the atmospheric pressure also. Okay, so in today's class, first we are going to see a consequence of the fluid pressure. Okay, so as you know that the pressure exerted by a fluid, if you can just recall, the pressure exerted by a fluid is given by a formula, and that formula is P equals to H rho G. Okay, I think all of you have remembered that the pressure exerted by a fluid is equals to P equals to H into rho into G. What is the value? What is the H? H is the depth of the liquid column. Okay, whereas rho, this symbol is stated as rho. Okay, the rho denotes the density of the fluid, whereas G is the acceleration due to gravity. Okay, so we have seen this in the previous class. Now, so can you imagine that as the depth of the liquid increases, the pressure exerted by the liquid also increases, isn't it? That is why we can say that due to this factor, due to this depth factor, okay, due to this depth factor, even if the fluid remains the same, the depth increases, the pressure exerted by the fluid also increases. This is one of the main reasons that you must have noted that when deep sea divers, the persons who go deep under the sea for various for experimental works, okay, or for various surveys, okay, they wear a special kind of suit, isn't it? So why they wear that kind of suit? Because that suit actually can withstand the high pressure of the sea water. They are going down into the sea water. Okay, see, so I can write one of the consequences is that first consequence, number one consequence, that deep sea divers, okay, wear special suits. Okay, special suits. So why this is important? Because when they go deep down the sea, the depth of the sea from the surface of the sea level increases. As a result, pressure also increases, and with the increase in pressure, that can actually cause harm to the human body. So they wear special kind of suits which actually can withstand the high pressure. Okay, so this is one of the consequences of the this factor. Okay, now the second application, you can also say that you have also seen the astronauts, the persons who go in space. Okay, those astronauts also wear a special kind of suit while going into the space. Because why? When in the outer atmosphere, in the outer space, not in the atmosphere, in the outer space, there is no atmosphere. So if we consider moon, okay, when the astronauts land on the moon, they wear special kind of suits. Why? Because there is no atmosphere on the moon. So what happens there? So same is the case. First, let me write the second application. Astronauts, okay, also wear special suits. Okay, why this is so? Because in the blood pressure of the human body does not change, isn't it? Even the person goes into the moon or wherever he is, the blood pressure remains the same. It is a fact. So if the blood pressure remains the same, now if the person is going, and astronaut is going into the outer moon, okay, on the lines of this moon surface, there is no atmosphere there. So what happens when you are on the Earth's surface? The atmospheric pressure, okay, that is a huge atmospheric pressure exerted by the Earth's atmosphere on us. And if we consider that the average area for an adult human body is 2 meters square, then we can say that the force or the thrust exerted on human body is about 2 lakh newtons. Okay, so it's a huge force that is acting on the human body. Why we are not aware of it? Because we are habituated to that force from the very childhood. Okay, so that is why we were not aware of that force. Okay, but it's actually working. Another factor that why we are not aware of this huge force or huge thrust that is acting on us is because of blood pressure. The blood also exerts certain kind of pressure, and it is equal to the atmospheric pressure. That is why you do not feel that pressure. Now think of the fact that when an astronaut goes to the outer space, okay, where there is no atmosphere, say lands on the surface of moon, okay, what happens there? The atmospheric pressure is almost negligible. It's becoming zero, almost zero. Now the blood pressure suddenly has not reduced. So what happens if the blood pressure becomes suddenly too much high? Actually the blood pressure has not become high. The blood pressure remains the same. Outside atmospheric pressure is decreased to a lot extent. In that case, the blood pressure can cause the veins or the arteries of the bodies to rupture. Even the body of the person can rupture, okay, can burst and blood can come out, okay. So it's a dangerous situation and the person can die. So to prevent that, astronauts who are going into the outer space wear special kind of suits, okay. So this is the second fact. Third fact is that have you visited any dam where water is being stored for irrigation purpose or for any other purpose? When water is not available in the dry seasons, the water from the dams are supplied for the irrigation purpose only, okay. So in the dams, what happens in the dams, if you see the construction of dam, the dams store water, okay, and if you consider the wall that is enclosing the dam, okay, say this is the dam, okay, if you consider the wall enclosing the dam, with the increase in depth of the water surface, what happens, the pressure increases. Now the water will exert more pressure at this point than at this point. So what happens, the wall of the dam is made thicker at the base, okay, is made thicker at the base or the lower end, okay. So this is the fact, that is why the dam walls are being made thick at the base end, okay, so that they can withstand the high pressure of the water, okay. So third point is that walls of dams are made wider at bottom, okay, at bottom. So this is the third application. So these are the few of the applications which you can see, or rather you can say that these are the few of the consequences that you can see due to the pressure exerted by the fluid, okay. And we have to keep these facts in mind. We have to keep this the pressure factor, the depth factor, okay, responsible for the pressure exerted by the fluid, and accordingly we have to modify the situations, okay. So these are the few applications. There are many more applications, but we will not be discussing any of those. Please study those applications, and if you can have any query, then you can definitely mention in the comment box. We will be just happy to solve your problems or answer your queries, okay. Fine. So these are some of the consequences of the pressure exerted by the fluid, okay. Next thing that we are going to study is the Pascal's law. What is Pascal's law? Okay. Now there is a very interesting fact, okay. Just let me, before discussing Pascal's law, just let me demonstrate, or let me explain it to you all, that what is special about the fluid pressure, okay. So make heading transmission of fluid pressure, transmission of fluid pressure, okay, transmission of fluid pressure, okay. Make heading transmission of fluid pressure, fine, okay. So what is it, what does it mean, okay. If I say, consider a container, a plastic bottle, okay, not very hard plastic bottle, a soft plastic bottle, okay. So this is a container like this. It contains water. There is a cap on the mouth, okay, cap on the mouth. Now it contains water, and say it is totally filled up with water, okay, fine. Now what happens, you must have seen that when, say, if you take some bottle like the bottle of the Bisleri, the mineral water, okay, packaged mineral water, those bottles are actually soft bottles, okay, the plastic is not so hard, okay. Taking those bottles, and if you fill the bottle complete with water, and then if you squeeze at any portion, what happens, if you squeeze at any portion, say if I squeeze at this portion, okay, you must have noticed, or you can notice that this squeezing effect, when you are squeezing the bottle at this point, this effect is transmitted throughout the bottle. It's a very important, it's a very interesting fact. The pressure, the squeezing effect is transmitted throughout the bottle. Now if you just make a single hole here or single hole here, what happens, when you squeeze at this point, that pressure can be seen to be affecting at these points also, and the liquid or the water that you have taken in the container just comes out of these holes, okay. So the pressure, that what I am trying to say is that the pressure that you are applying at any point in a enclosed liquid, over enclosed liquid, what happens, that pressure is being transmitted to all the parts of the container, okay, to all the parts or throughout the mass of the liquid, okay. So this is what the Pascal's law says, or this is what the Pascal's law is all about. So what is Pascal's law? What is Pascal's law? What does the Pascal's law say about, okay. So actually Pascal's law says, or Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions. Okay, so this is the Pascal's law, that when you apply pressure over any point over a confined liquid, okay, that pressure is transmitted in all directions undiminished, okay, throughout the mass of the liquid. This is the Pascal's law. So I think the Pascal's law is clear. So if I, for the clarity, let us just write it once. Okay, so Pascal's law states that the pressure exerted over any point, okay, pressure exerted, say anywhere in a confined liquid is transmitted undiminished in all directions, okay, throughout the mass of the liquid, okay. So this is the Pascal's law. So what we have seen in the case of the bottle, squeezing up the bottle, basically Pascal's law states that thing only, that if you apply pressure at any point on the confined liquid, that pressure is transmitted to all the directions and in all the mass of the liquid undiminished. Okay, it's a very important fact. So this is basically Pascal's law. Okay, so actually there are many applications of Pascal's law. So what are the applications of Pascal's law? So we will be covering those applications of Pascal's law in the next video. Okay, we are making just short videos to so that you can understand, or you can just learn it very short manner. Okay, so we will be seeing the applications of Pascal's law in the next class. Okay, so till then, please do study well. Thank you. Goodbye.